There was a time when just seeing it roll around the corner made you stop and stare. Sleek, curved, and like nothing else on the road. The GMC RTS wasn't just a bus, it was a symbol of the future. Here's why it became America's coolest and most unforgettable transit icon. In the early 1970s, America's cities were growing, but its public buses looked like relics from the past. Boxy, loud, and outdated, most transit vehicles hadn't changed much since the 1950s. General Motors saw an opportunity. They didn't want to just improve the city bus. They wanted to revolutionize it. The result? The Rapid Transit Series, or RTS. This new bus was born out of a bold vision to design a mass transit vehicle that looked like the future and functioned like no bus before. It all started at GM's truck and coach division in Pontiac, Michigan. The company wasn't just reacting to change, they were pushing it. The early 1970s were defined by oil crises, rising urban populations, and growing concern over pollution. GM wanted a bus that was more efficient, more comfortable, and visually striking enough to change how the public felt about transit. The first prototypes were unveiled in 1973 under the name RTS-2, showcasing features that no city bus had ever attempted. A streamlined fiberglass body, modular panels, futuristic curves, and even a planned hybrid electric drivetrain. These were buses designed with ambition. While some features would evolve or get delayed, the foundation was revolutionary. This wasn't just an engineering project, it was a branding move. GM marketed the RTS as the next evolution in American mobility. It was introduced to city officials not as a bus, but as a vehicle for tomorrow. Transit systems across the country took notice. By 1977, production began, and public transportation would never look the same again. The GMC RTS wasn't just designed, it was sculpted by airflow. At a time when most transit vehicles were engineered for function alone, GM went a step further. They used wind tunnel testing, typically reserved for race cars and aircraft, to shape a city bus. This advanced aerodynamic work began in GM's own wind tunnel facilities, where designers studied how air flowed around the body. The result was a strikingly futuristic profile, a steeply sloped windshield, rounded front end, gently curved side panels, and a tapering roofline toward the rear. Every line served a purpose, reducing wind resistance, minimizing turbulence, and helping the bus slip through the air with greater efficiency. These improvements weren't just cosmetic. Reduced drag meant better fuel economy and less strain on the engine, particularly important during the oil-conscious 1970s. Passengers benefited from reduced wind noise and smoother rides at higher speeds, especially on suburban or express routes. One of the most impressive engineering achievements of the GMC RTS was its air suspension system, a technology typically reserved for high-end luxury vehicles or motor coaches, not city buses. But GM wanted the RTS to feel different. The goal wasn't just to move passengers from point A to B. It was to make the ride feel effortless and smooth, no matter how rough the road was. Instead of relying solely on steel leaf springs like most buses of its era, the RTS used a full air suspension setup, incorporating rubberized air bellows filled with compressed air. These bellows automatically adjusted to road conditions and vehicle load, allowing the bus to float over potholes, curbs, and uneven pavement. It was a game-changer for cities with aging infrastructure and unpredictable streets. For passengers, this translated into a quieter, more comfortable experience. The usual bouncing and rattling common on older buses were dramatically reduced. Onboard conversations didn't have to compete with clunky suspension noise, and long commutes felt less exhausting. Drivers benefited too. The improved stability and reduced vibration meant less fatigue over long shifts and better control when maneuvering through tight urban routes. While the GMC RTS is often praised for its exterior styling, its interior layout was equally groundbreaking. General Motors reimagined the passenger cabin with both form and function in mind, combining comfort, visibility, and modern design to elevate the riding experience in a way no other transit bus had before. Instead of the traditional straight rows found on older buses, the RTS offered a slightly curved and staggered arrangement that created a more open and comfortable space. This design also improved passenger flow and reduced the feeling of crowding during peak hours. The RTS featured panoramic side windows that curved upward with the roofline, allowing natural light to flood the cabin. These windows weren't just aesthetic. They gave passengers a broader field of vision, making rides feel less claustrophobic and more connected to the outside world. The ceilings were higher in the front, creating a sense of vertical space as passengers boarded. Interior lighting was more diffused and evenly distributed, reducing harsh shadows and glare. Overhead, grab rails were thoughtfully placed for standing riders, and the noise insulation was noticeably improved compared to previous GM models. Another innovation was the rear engine placement, which allowed for a lower floor design in the front half of the bus. This meant fewer steps during boarding and easier access for passengers, even before ADA requirements were introduced. The driver's seat in the GMC RTS wasn't just a place to operate a bus, it was a purpose-built cockpit, inspired by automotive ergonomics and even aviation design. In an era where most transit buses had flat dashboards with scattered controls, the RTS introduced a curved instrument panel that wrapped around the operator, placing switches, gauges, and levers within easy reach. This layout dramatically improved driver comfort and efficiency. Everything was positioned with visibility and usability in mind, reducing the need for unnecessary movement during operation. One of the most forward-thinking design features of the GMC RTS was its modular body panel system, a concept far ahead of its time in the public transit world. While most buses of the 1970s were built as rigid, welded bodies, the RTS broke that mold with a bolt-on, segmented exterior made primarily from lightweight fiberglass and sheet metal. Each side of the bus was divided into individual panels that could be easily unbolted and replaced without cutting, welding, or repainting large sections. This innovation dramatically simplified maintenance and repair. For transit agencies, it meant that damaged panels, whether from accidents, corrosion, or wear, could be swapped out quickly, often in just a few hours. The bus could return to service faster, reducing downtime and saving money. Fiberglass also provided resistance to rust, dents, and road salt, a major advantage for city fleets operating in harsh winter climates. Additionally, because the panels were standardized, they could be stocked in inventory and used across fleets, streamlining logistics. Beyond practicality, this modular approach contributed to the RTS's futuristic appearance. The seams between panels gave the bus a clean, aerospace-like look, reinforcing its image as a next-generation machine.